Hello world, how are you this evening? Welcome back to Building a Roguelike in C, the stream where we are building a classic roguelike, classic ASCII roguelike, using standard C, and we're doing it without any pre-built engines. We're going to build our game engine ourselves. And figure out the algorithms involved. And speaking of algorithms, yesterday I believed that I had finished up work on our shadow casting field of view algorithm, and I was rather giddy with having completed it because I had thought about it for a few days beforehand. And then I was running through the game again and realized that my shadow casting algorithm wasn't actually casting any shadows, which is kind of the point. It's like right there in the name. I did. I was gonna wait till I was back on stream to kind of do some debugging, but like it was bothering me so much that I just kind of dove right in and put it into the debugger and figure things out. So let me show you where I ended up right now. Let's put this up here. I was so excited that I had figured out the mapping between map space or from my local space to map space, and that was working properly, but the shadows themselves were not present. And I'll walk you through the changes I made, but you can kind of see where we're at now. We're casting shadows, and so like if I go around the corner here, I can't see down that hall anymore. Now you'll notice it's not perfect. So like if I stand against the wall here, the way that it's calculating the slopes, it's marking part of the walls as invisible, which is kind of weird. But I mean the algorithm is working as expected right now. It's just we're going to need to tweak it a little bit. And you can see now, like, I wish I had saved it beforehand. Oh, you can't see the game, huh? No, that would, like, really help. Oops. Okay. Sorry about that. So here's the game. You can see that we're properly casting shadows now. And as we, come up to it, let's see if we can find a good example of just like, okay, so here, like, we can't see down that open space, but then when we come around the wall, underneath this part right here, we can kind of see these. So we're casting the shadows properly now. This is a good spot right here, so we go behind the wall. Now we can't see any of this stuff, but we come over here, and we can see all that. So it's working now. I just want to go over some of the fixes that I needed to do. So let me hide the terminal here. I'm going to bring up I have the diff here in Git. I haven't committed this yet. I'll commit it after this stream, but there were a couple things that were busted. The first being that I was not cleaning up my shadows. So once I got the shadows working, they were being applied everywhere, so I was basically wandering around in the dark. I couldn't see anything because it thought that everything was in a shadow. So I needed to reset that for each sector, resetting the shadow count. And then I realized that when I added the translation for to go from local sector space to map space, I was still looping according to map coordinates. So I needed to clean that up. I took the map coordinates out of that. The other thing I wasn't doing is I was never actually setting this previous blocking flag. So I would scan across to the end of the span, and I would check when you fall out of that loop. You check to see if previous was blocking in order to close the shadow. And since we were never setting it, we were never actually closing the shadow and adding it to the shadow list. So fix that up. This is more coordinate stuff. And then the biggest problem, well, not the biggest, but this was basically when we're scanning in a sector from 0 to 45 degrees, I was assuming that the slope was going to give us values between 0 and 1. And actually what would give us values between 0 and 1 is if we took the inverse slope. So that's what I'm doing here. I've changed it to be, instead of the normal slope y2 minus y1 over dx, I'm doing the inverse of that, so it's dx over dy. And that has given us our current success. So that said, let's go back in. This looks pretty good, but I don't like the fact that it's assuming that this is invisible because it's behind this. So I need to adjust our angles a bit. And so that's actually, let's think, that would be in sector 2. And what's happening it's the so it's when we're setting, let's look. So when we are starting a shadow, right here, calculating the start of the shadow, we're taking the line slope from the origin, and then we're drawing that to between the origin and the leftmost edge of the cell, instead of drawing the line directly through the cell. And I think if we draw the line directly through the cell, it will be more forgiving about those shadows. So let's remove this 0.5 that we're taking off. And see, I'm gonna do a build and see what happens. So that looks better. So now if we're moving along the lines, we get those, we can see all along the wall. And then when we're in the hallways, we can see. That seems to be a lot better. Did we break anything? So, I mean, what we lose is that since this slope is now going between, instead of being against the edge here and hiding this second wall cell, it's drawing it straight through, so it's making that visible. But I think I can live with that. Now, there's an alternative that we could do. that seems okay, because I think the alternative is when you're in a corridor and you don't see the lines, don't see all the walls, you see like one block missing. I think that's weird. So I think that that's a reasonable trade-off. In certain situations, it doesn't look exactly accurate, but I think that's better than the alternative. Alright, so now you'll notice I had unchecked my task list. I think I'm going to actually mark that one off now and call that one good. Now the other thing, the next thing I'd like to do, I've talked about this for a couple times now. The way that we're doing world state right now is not very efficient. It's just kind of easy, and it was an easy way to get started. But right now we're allocating, 10,000 game objects and positions and visibility components and physical components. And not only is that inefficient, it's I don't like having that artificial max on our on our world state. So what I'd like to do is build out a linked list data structure, a generic linked list that will allow us to grow our list of game objects dynamically, and if we, every game object isn't going to have necessarily every single component, so we're wasting memory right now by leaving gaps in these arrays. So I think building out a dynamic linked list that will handle allocation and deallocation of memory only when necessary will greatly improve the performance here, memory-wise. So one thing I'd like to show you real here, I hit up the Amazon and ordered a used book from, I think this one came from somewhere up in Northern California, Mastering Algorithms with C. It's kind of old school. And do you know why it's old school? I have unearthed a computer archive. Look at what this says right here. Hopefully you can read that. Includes diskette. Now, some of you younger folks might be asking, what's that? I don't know what that is. Well, let me educate you. This, ladies and gentlemen, is a floppy diskette of the 3 1/4 inch variety. I'm sorry, 3 1/2 inch variety. It's been so long that I forget them. There used to be 5 1/4 inch and 3 1/2 inch floppy disks. These were the hard ones. The other ones were floppier. This one doesn't flop that much. But I believe the capacity for this is like 1.44 megabytes. But it doesn't really matter what the capacity is because I don't actually have any way to read it anymore. I haven't owned a computer with a floppy disk drive in well over a decade. So, but I thought that you might get a kick out of that. I did. It's been a long time since books came with floppy disks or even CDs. So that said, now once we've visited our history, I've actually already started implementing this, just kind of modifying slightly the implementation that's outlined in this book. There's some great data structures here in the book. I'm sure that we'll end up diving in here for some of these others in the future. They've got binary search trees and queues and stacks and all sorts of fun stuff. But right now we're concerned with lists, and specifically a generic list that will allow us to hold any sort of data. So I've outlined a few structures to represent that list. The first one being list element, which represents an element in the list. And it has got two data members here. The first is a void pointer to data. And this is where it's, this is what makes the list generic, is that we're not casting that pointer to any specific data type. So we're free to assign any sort of data to an element that we would like to. Now, the rule for these lists is you can't just stick one type of data in the first element and then a different type of data in the second element. The list needs to be homogeneous, but it can contain any single type of data. So the next structure is the actual list itself, and this takes, this has a size, and then I'll skip this for a second. Then we have a pointer to the head element and then the tail element of the list. And then this last bit is a function pointer to our custom destroy function. So basically you'll see when we're creating the list, we give it a pointer to a function that will be used to free up the dynamically allocated memory within an element. So if we just use malloc to allocate that memory, we can just pass it free. But if we need a bit more customization, then this gives us the flexibility of being able to clean up the exact data that we've stuck into the list. And so the next bit here, we've started to define the interface for this list. A couple of macros for the easy stuff, just a way to get the list size, and then the head and tail elements of the list, and then some data access for the element level. I can pull the data and the next pointer for the element. And now we're getting into the actual functions that we need to implement. So I've already done list init, which is pretty simple. We're just initializing our size, we're taking this destroy function pointer and assigning it to our destroy member, and then setting head and tail to null. So it's list init creates an empty list. I also finished the list destroy algorithm method, which basically will loop through the list and remove each element from the list, and once it's removed, it has a pointer to the data that was contained in that element, and it will call the custom destroy function on that data, so cleaning up any dynamically allocated data. And then it just clears this structure just for good measure before we exit. So what I'm working on right now is the list insert function, and I'm gonna jump in here. So the first thing that we want to do is we want to allocate the storage for the element itself. And so we'll say if our new element is so our new element, that's right, we need to cast it, so it's a list element. And a malloc and it'll be, we'll take the size of, we're going to want to malloc the size of a list element structure. And then if that's equal to null, we're going to return false because that means that we were not able to allocate the memory. Now, hopefully we'll never hit that. But assuming that that was successful and we didn't return out of this case, then we're going to insert the element into the list after we assign the data. So new element data. Passing in data, and then if the element indicated, this is list insert after, and so you give it the element that you want to insert after. If this is null, that means we want to insert it at the head. So we'll say I'm missing the name of my variable up here. So if our list size is 0, then we are setting set list tail. Tail also gets set to the new element because when there's nothing in the list, then the head also is the tail. Right. So now we're going to set next for the new element. Next equal to the head of the list. So what this will do is, if the list is empty, then list head will be nil, and it'll properly set new element next to null. Keep saying nil because I code in Swift and Objective-C during the day, and we use nil instead of null. So if it's null, this will be set to null properly. However, if the list is not empty and we're doing insert after and assigning it null, it means we want to shove it into the head of the list, but we don't want to lose all the other stuff in the list. So we're assigning new element next to the current head of the list. And then what we're going to do is we're going to assign the list head to new element. So if there was a non-empty list, then the previous head of the list is now the second element in the list. And we've got our else. So if the element is not null, and we're given an element to insert after, So if element arrow next is null, then that means that the element that we're inserting after is the current tail of the list. So we're setting the new tail to be our element. Similarly, we're going to do new element next is our element. Next. And then our element next is going to be our new element. And then finally, what we need to do is increment the size of our list. And return success. So what we'll do, the last thing that we're going to need to do is we've done our add, now we need to do a remove. And so this is going to remove the element, or we're going to remove the element after the given element. And if the given element is null, it will remove the head of the list. And it's going to put the data pointed to by the element we're removing, it's going to put that data right here in the third parameter. So oops. First we'll want to check against empty list, so if list size turn false, because that's not good. And then so handle the removal from the head of the list. So we're going to do our list. Get a, is this a pointer to the old element? It is. It's a, this should be a pointer, I was going to say. Let's just double check our, yep, that's a pointer as well. Okay, so looks good. Alright, so what we've done is if we're removing from the head of the list, we grab a pointer to the data, and then we point old element to the element that's at the head, and then we move the head pointer to the element that the current head was pointing to. So then if we want to remove from somewhere else in the list other than the head, let's do check and see if this is actually pointing at the tail. If it's pointing at the tail, we can't remove what's after the tail because there is nothing after the tail. So we'll also return false in that case. Otherwise,
despite the wall in my head said hello to you.
do similar. Grab a pointer to the data.
They were chasing yours all around the room. Chasing yours all around the room. I used to be in love with heartbreak, but now I need drugs to ease the pain. I used to want to hide my love from you.
Element, next.
I used to be in love with heartbreak.
Next. So what we're doing here, let's just finish up the so what we're doing here is, again, grabbing a pointer to the data from the element that we're about to get rid of, and then grabbing a pointer to the element itself, and then we're essentially removing that element from the list by marking the element's next pointer to be the one following it. So essentially, we remove our pointer, our link in the chain, to the element that we're trying to destroy, and we pop that link out, and then we join the existing two back together. So the next thing, what we need to do, we've popped it out of the list now, but we need to go ahead and clean up our memory. So the first thing we need to do is free our old element, this element struct itself, which was, you remember, we mallocked, so we're going to free it. And then we're going to adjust the size of our list. And return true, because we're done. Now you'll notice that we didn't clean up the data contained in the element, and that's because it's up to the user of the list to clean up the element data. So theoretically, they're probably, if they're removing it and they want to use that data, they can do that. But it's on them to clean it up. The only instance where the list will clean up its own, or the data in an element, is if list destroy is called. Then we'll go ahead and clean up all of the memory allocated for the list, including the data of each element. So I think that's pretty much it for the implementation of our list. Let's throw this in the code base and then compile it and see if everything's working as expected. I'm going to bring this, since this is going to be used throughout our game, I'm going to pop it in before some of our other includes. Oh boy, okay. So right from the get-go, line 7, missing. It doesn't like list element, huh? Identifier list element, and then 8. Wait a minute. It doesn't like this. Pretty sure that's... Oh, do I have to do it as... Because I haven't named it yet? I wonder if that's... what I need to do. Okay, yeah, that cleared that up. I needed to, since I hadn't type defed it yet, I needed to use the full struct and the name. So let's see, list remove after redefinition. Line 111. So I must have somewhere else. Oh, if I'm using it up here, I need to have declared it. So maybe what we'll do, just I could have declared the function up towards the top here, but this is fine for now. Okay, 93. Expected a form parameter list, not a type list. Oh, again, I didn't name my list. I think I even use it down here. Yep, I had the same issue, and I caught it in the insert after, but I didn't catch it in the remove after. And then we have a mem set. Oh, we just don't have the rights. 64. That can't be right. Memset. I call memset when I'm clearing the string. So what? Oh, it's size of no size of list. List here on size of list. That seems okay. Let's make sure that it's the only place I'm using it, so it's complaining about this bit. Lists here on size of, okay, so differs in levels of indirection. Not even sure what that means. Let's go to the rules. it's actually... Oh, is this treating it as an error? Seeing that as a warning, it can be a warning. It says the compiler comes across a function it does not have a prototype for. It assumes the compiler will return int. So it's as if it doesn't realize that I've included standard lib. Maybe... Nope, it's right here at the very top. So standard lib definitely comes in before list. Let me just verify that memset is part of... Maybe that's the problem. Maybe memset isn't part of standard library. Is it part of string? It's part of string.h. Whoops! That's the problem. Okay. So we'll bring in string.h. And then hopefully be able to build. Yes. Okay. So now we have the concept of a linked list or a generic list. Yeah, I get you a lot, huh? Yeah, I think it's actually tripped me up before, but you know, shame on me for falling for that one twice. Oh, Mr. Fourth Dimension, I got your note about testing out 4Coder, and I was playing with it again this afternoon, and I'll show you. It's really weird. Let me just add a window source real quick, and then I can fire up 4Coder and show you what it looks like. And I'm not sure if there's a different mode that I can be running it in. A window source. And I'm adding it as a window source, so So if you'll notice, I think you can see this on the stream, it's up here in the top left. It's really weird. It's like it captures the whatever is in that window space, and this is OBS. I mean, the window looks fine on my screen, but OBS it does something weird with the memory, and it never refreshes this window. So it kind of takes a snapshot of whatever happens to be on the screen behind that window at the time, and uses that as the window. But we can, I'll shoot you an email with a better description, but I just wanted to show you what I will write you about. Because it'd be really cool if I could get OBS to play nicely with 4Coder, and then I could use 4Coder for coding. Okay, so we've got a list. We've got our field of view. Not sure how late I want to go tonight. And I think I'd like to think about and really look at the code for a bit and think about the best way to use lists as our world state data structures. Yeah, I'm using OBS Studio if that helps at all too, and so it could very well be. I did notice that there was a new version of OBS Studio that came out today, so I will upgrade after the stream and see if that makes any difference. But I know that they're still building out several of the plugins and tweaking the existing ones. So I've had problems with like game sources as well. I can't manage to get the game source to work either. So it probably has nothing to do with 4Coder itself. But yeah, I think I'm gonna call it a night now, and then kind of take a few minutes and look at this, look at the current world state, and then look at the changes that I'm going to need to implement to use the dynamic lists as our data structures for capturing world state. So I think we had some success. We fixed our shadow casting algorithm that is now actually casting shadows. Yay. And finished out our implementation of a linked list. And we will put that list to good use next stream. So I'm going to call it a night. Thanks for watching. If you'd like to be notified the next time I go live, be sure to hit that follow button and you'll get a notification when my next stream starts. You can check out archives of previous streams on YouTube. Hit me up on Twitter at PDCodes with any questions or comments, and then I'll be committing the current source code in just a few minutes, and you can grab source code for the project on GitHub, so you can play along at home. So thanks for watching, and I'll see you again soon.